how do you write, how do you read this equation? You can't read this as 2 grams of magnesium reacts with 1 gram of O2 gives me 2 grams of MgO. You know, the key in solving problems, the keyword in chemistry is not grams, it's moles. 2 moles of Mg reacts with 1 mole of O2 to give you 2 moles of MgO. You want to convert it to grams, you can, but you have to start with moles and then convert to grams. Equations are not written in terms of gram, they are defined in terms of moles. So this is how you read this chemical equation. You can say 2 atoms of magnesium reacts with 1 molecule of oxygen to form 2 units of MgO. And mole is certain large number of units, so I can multiply both sides by Avogadro number and read it in terms of moles, which is more familiar for us. 2 moles of magnesium react with 1 mole of oxygen, 1 here. You produce 2 moles of magnesium oxide. And not, well, yes. You want to convert it to grams? Yes. Every mole of magnesium is 24.3 grams multiplied by 2. You get 48 grams of magnesium, reacts with 1 mole of oxygen, which is 32 grams. And it makes 2 moles of magnesium oxide, which is 80.6 grams. So you can translate it from moles to grams, but you can't read the equation in grams. In other words, it's not 2 grams of magnesium, but 48.6 grams. It's not 1 gram of O2, but 32.0 grams. It's not 2 grams of MgO, but it's 80.6 grams of MgO. So you make significant error if you read a chemical equation in terms of grams. Always read them in terms of moles and then translate it from moles, from definition of moles to grams. So it is not 2 grams of magnesium, 1 grams of oxygen to make 2 grams of magnesium oxide. I hope these make sense to you. If they don't, please come and see me. I really appreciate to have an opportunity to discuss these with you on Zoom. So let's apply all these to solving this problem. So this is called methanol. It burns in the air. Burning is combustion. Combustion of carbon results to CO2. Combustion of hydrogen results to water. And you see all the balancing coefficients. So you see the stoichiometry, the relationship between number of moles of reactants and product. So we are asking you if amount of starting material is this. If you use 209 grams of methanol, how much water do you make? Is it fair to say that we always solve chemistry problems in terms of moles? You are given grams, convert it to moles. So can I start with the amount of starting material, which is 209 grams of methanol? So I can start with grams of methanol. Always solve chemistry problems in terms of moles, so I can convert grams of CH3OH to moles of CH3OH. And then, is there a relationship between number of moles of CH3OH and water? Yes, the ratio is 2 moles. It's producing 4 moles. So if you have moles of CH3OH, you can determine moles of water. And if you have moles of water, every moles of water, how many grams? 18 grams. So you can convert number of moles of water to grams of water. So this is our plan. In solving any chemistry problem, write a plan for yourself. The same way, if you want to go from here to a vacation, you write a plan. You have to buy air ticket. You have to make a reservation for the hotel. You have to know what you're going to take with you. We do the same thing in chemistry. You plan step by step. What you're starting with, right in here. What is problem asking, that's where you have to end up. How do you get from a starting point to the end point? Stepwise, write a plan. Don't forget to use moles. So, what do I need to convert grams of methanol, CH3OH, to moles of CH3OH? I need molar mass. Once you have moles of CH3OH, how do you go to moles of water? How do you do this? What do you need? Do you need a stoichiometric coefficient? The ratio of 2 to 4 will take you from moles of CH3OH to moles of water, right? And once you have moles of water, what do you need to convert that to grams of water? You need molar mass of water. If you have 10 moles of water and each mole of water is 18 grams, obviously you have 10 times 18, right? So let's do this. Starting material amount 209 grams. I want to convert it to moles. So I want to cancel grams of CH3OH and go to moles of CH3OH. Where do I write grams of CH3OH to be canceled with grams of CH3OH? On the bottom. So these two can now cancel each other. So I'm left with moles of CH3OH, which I'm writing here, right? Next step, I want to cancel moles of CH3OH and go to moles of water. Where do I write moles of CH3OH? Do I write moles of CH3OH on the bottom so these two can cancel? And I want to convert to moles of water. So I write that on the top. How do I find relationship between moles of water and moles of CH3OH? Here. Every 4 moles of water is obtained from 2 moles of CH3OH. So now I have moles of water, but I want to go from moles of water to grams of water. That means cancel moles of water. Where do I write moles of water? On the bottom. I want to convert to grams. I write grams of water on the top. So moles of water and moles of water are canceled. I'm left with grams of water. Is this the unit that problem is asking? What is problem asking? Mass of water, grams of water. That means whenever you get to the unit, which is the unit problem is asking, that's the only unit which is left. You're done with unit conversion factor. So all you have to do now, enter the numbers in your calculator. And do you see one more time? Just double checking my units were grams of CH3OH and grams of CH3OH are canceling. moles of CH3OH, moles of CH3OH are canceling. Moles of water and moles of water are canceling. I'm only left with grams of water. That's what problem is asking. So this is where I stop and do calculation.